As you can see, this is the fluorescence image of the slide. So this is citra fibbrata. You can see the fibrous structure of the fungus. So these are the tuberculosis of the fibbrata, the tiny tubercules, or actually tubercules of this fungus. So these also consisting of platelets also. These platelets actually consist mycotoxin, these tiny platelets. These actually forms the tubercules, and tuberculosis forms the citra fibbrata. Now you can see the fibbrata. The more tuberculosis are visible here, you can see the absolute picture, clear picture of the tuberculosis. So also the fibbrata. This is the fibbrata geometry actually. This is 400 times magnification. You can see the fibbrata geometry. So that is why it is called citra fibbrata, because of its fibrous structure. So these are the more tuberculosis. We have to focus it because we are running very fast. So this is focusing. This is a tiny tubercules. So this is the more tiny tubercules. This actually forms the citra fibbrata. This elongate and forms the citra fibbrata. So these are the microscopic spores. This consists of the platelets and the mycotoxin. The expected mycotoxin is patulin, but supposed to be patulin, but that is depending upon the examination, whether the UV spectrophotometer examination, UV spectrophotometrical examination, that will reveal the main thing. So now this way they're seeing more tuberculosis, tiny tuberculosis, and you also see the platelets in the right hand side corner of the screen. You can see the platelets, the tiny platelets. Platelets are accumulated to one place. So this is the fibbrata. This is the one single fibbrata. You can see more fibbratas. These are the long fibbratas. This is the absolute geometry of the fibbrata, which you can see in the fluorescence image. This is the image is now clear. So this you can see the absolute geometry of the fibbrata. So the very nice fluorescence. This is the actual purpose of this fluorescence microscopy, which shows you the exact information inside the. Hello friends, so we are back after a long time, because we are now, this time we was investigating the mycotoxin of the citra fibbrata. As you can see, the mycotoxin is over here. I'll show you just a moment in the camera that this fungus is actually having five mycotoxins actually, rather. The most three dangerous mycotoxins and other two are the mycotoxin, with a special one having a violent DNA, and this violent DNA mycotoxin is known as ustiloxin. This ustiloxin is actually forming these fibrous structure. This is responsible for forming these fibrous structures, which is consisting of 3 amino acids, and this is a violent mycotoxin. So this can change its arrangement. This 3 amino acid combination, it can change the combination and it can become a violent. So it can be ustiloxin A and ustiloxin B. So these two combinations it can change, and both of the combinations are present in this mycotoxin, as you can see. So therefore, after we have investigated this mycotoxin, and the second dangerous one is the Tremorgens. These Tremorgens is very bad mycotoxins. They can do anything else, they can do any dangerous activities inside our digestive system. So if we take this orange, we ignore this fungal orange and we take inside, and we will be totally disrupted out. So many diseases it can create. It is beyond our expectations. These Tremorgens are, as you can see, this is the mycotoxin. It's bottled in this mycotoxin, and it has been leveled. 5 mycotoxins you can level. The camera is not very good. My camera is not very good. Anyway, we can see the mycotoxins. So this has been bottled. Especially it has been extracted and kept in a bottle. We did 3 successive experiments. The first one was normal. That I don't recommend here. The second one was the extraction of moliniform, and this moliniform mycotoxin is a very bad mycotoxin, as you can see, and it is the main structure of the fungus. And after that we have the Tremorgens, the 3 Tremorgens, and the ustiloxin, the 4th one. So this we have discovered, we have extracted through this UV spectrophotometry, and we have detected with the help of UV spectrophotometry, and so I'm here with that, and Therefore, I want to say that this I had a lot of going through this lot of experiments for this extraction of the mycotoxins, and the three consecutive experimental stages were there. The first one is normal with the help of acetone, refrigerated acetone and KVR, alcoholic KVR solution, there is alcoholic potassium bromide solution, and that is done. But that didn't reveal the mycotoxins. It came near to the spectrum, the UV lambda max, but it didn't give the exact lambda max of the exact peak of the mycotoxin. But the second extraction procedure, this methanol chloroform mixture, 1:1 methanol chloroform mixture, revealed the moliny form. And the third one, the DMSO solvent, was gave the exact structure, exact definition of usilotoxin, the aflatrem, and the lolitrem with xanthotoxin. These three dangerous things, the aflatoxin, aflatrem, the xanthotoxin, and this lolitrem. These are the absolute dangerous mycotoxins. These three can rupture our stomach, our intestine and everything. Even the colorectal system, the kidney can be damaged, the testicles can be damaged, the reproductive system of human being can be damaged, the ovary can be damaged, the uterus can be ruptured, the uterus, you can have a heavy bleeding inside the uterus because of this fungal infection, and the cervical infection, the women can have a cervical infection with this massive fungus, the citra fibbrratta. So be careful about the oranges in the winter season, as well as I can say, and be good and enjoy 2022. So I will be showing you the UV curve in the next part of this video, and we will be getting the two consecutive videos of this regarding these two consecutive files. This and about this another thing about this usilotoxin. Usilotoxin is a viral DNA, a viral mycotoxin. It has two viral combinations, or the three amino acid combinations, as I have said earlier. So this is three combinations. This is a viral variant mycotoxin. So this is more dangerous. This is dangerous than Tremorgens, as dangerous than Tremorgens. So be careful about this citrus. If you see something white, some white patches inside the orange, immediately discard that orange. Do not touch it inside. When you don't touch it inside, just discard the orange. Be careful, discard the orange. And well, now I will just show you the UV spectrum. Just two spectrums I will show after this presentation. I will show you the two spectrums, and we can see. So friends, the spectrum has come. This is the spectrum file of the first spectrum. This is the first spectrum of the first file, and you can see it is mononiform. Has come. It is into 20 nanometer. It is showing. This is the mononiform waveform of the mononiform. The right side, this is nothing. So this is the only concern about the left hand side, and this is the second slide consisting of the other three mycotoxins, other four mycotoxins actually. You can see the gap between the two plateaus. Two plateaus are there in the left hand side one and the right hand side one. So in these two plateaus, we are concerned about the Tremorgens. So there is the aflatrem at 230 nanometer, as you can see, and the other two are the lolitrem and the xanthitrem are the other two at 228, and then the third one has arrived is the usilotoxin. So that is the main variant, the viral DNA variant. So these two are the usilotoxin, and at the 200 and 203 nanometer. So these are the five mycotoxins you can see in this file, the spectrum waveform file, this electro UVI spectrum. So this is all about citra fibbrata, mycotoxin, and fluorescence study and other studies. So thank you very much.